This is Unit 10, Day 2, Graphing Exponential Functions. After watching the video, you should be able to say yes to the following statements. After watching, you should be able to graph an exponential function and a translation from a parent graph. And you should be able to describe and explain the difference between linear, quadratic, and exponential graphs. All right, if we go down to our first equation, what we're going to be working on here is being able to graph each equation. So as a review, a linear function has an equation that looks like this: y equals mx plus b. So if we are to first graph this equation, y equals 2x, we need to know our m is 2 over 1. And our b isn't shown. So if our b isn't shown, we know that our b is 0, 0. So let's start by graphing that. So we start with 0, 0, and we use our slope to make our next point. 2 up, 1 over, 2 up, 1 over. Go the opposite direction, 2 down, 1 over, 2 down, 1 over. And we make a line to connect that. So we know that a linear function looks like a line. Linear line. Okay. So what they're asking next is, what is the m? Well, it should be a review. The m is going to be your slope. And in this case, m was 2 over 1. What purpose does it serve? Well, it tells us the rise over run. So this should all be nice review. It's going to tell us whether our line is going to be horizontal, whether our line is going to be vertical, if it's going to be going up, if it's going to be going down. That's what the slope tells us. Okay, next thing, what's the b? So what does this b signify in this equation? Well, we should know, again, review, that's the y-intercept, wherever it crosses that y-axis. So we know for this equation it was 0, 0. And what purpose does it serve? Well, it tells us where it crosses that y-axis. Okay. And last thing they ask, what does the graph look like? A line. Linear line. Okay. Next type of function is an exponential function. And this should be, you've already seen what this looks like, y equals y equals ab to the x power. So if we first need to graph this, y equals 1 times 2 to the x power, what you're going to use to graph is a table. So we're going to take our x values and plug it in to that x 5 times to find 5 points. Alright, so this is going to take you back for a little review. If we have our first one, y equaling 1 times 2 to the negative 2, because we're going to take that first x and plug it in, we need to simplify this. So y equals 1 times, well, we can't have a negative exponent, so we know if this is over 1, we need to move this down. So now it's 1 over 2 squared. When we move it down to the denominator, the negative disappears. So 1 times 1/4, 2 squared is 1/4, is 1/4. So we take that information, and that is our first point, negative 2 1/4. Now next one, block this off here. Same idea, another review. So 1 times 2, now to the negative first power. So we know we can't have a negative exponent, so instead of 2 to the 1 power, we're going to move it down to the denominator, 1 times 1 to the 2 to the 1 power. So we get 1 times 1/2, which is 1/2. Okay, next ones are a little easier. If we do the next one up here, the little scratch, 1 times 2 to the 0 power. Well, a reminder, anything to the 0 power is 1. So 1 times 1, 1. 1 times 2 to the 1 power, well, this gives us 2. 1 times 2 is 2. And 1 times 2 squared, this is 4. 1 times 4 is 4. Okay, so I have my 4 points, so I'm going to graph them. So 2 and negative 1/2, or sorry, 2 and 1/4, negative 1 and 1/2, 0, 1, and 1, 2, and 2, 4. So now if we connect those, we have a curved line. And this line is going to go on beyond, but it's never going to really cross that x-axis. So we have a curved line. So we need to figure out, what does the A stand for? What does the B stand for? So the A is the y-intercept. Okay, so when x is 0, that's going to be our A. So this piece of this middle point is really important when you're going later on in the next examples, when you're going to be actually writing a function rule. Okay, so that's A. A is always y-intercept. What purpose does it serve? Well, it tells us our initial value when x equals 0. Okay, and it also affects the steepness. So when A is bigger than 1, it gets steeper. When A is between 0 and 1, it gets less steep. Okay, so now we have A. What's the B? Well, B is the growth factor. Okay. It's going to tell us if we're going to be having decay or growth. So what purpose does it serve? It tells us if it's going to grow or if it's going to decay. If B is bigger than 1, it's going to tell us that it's going to grow rapidly. And if B is between 0 and 1, we're going to have decay. Okay, and what does this graph look like? Well, it's a curved line. Okay, so linear line, straight line. Let me add the word straight in here because we have curved down there. Exponential curved line. Quadratic, really quick, it's not in the notes, but I want you to sketch a quadratic. What it looks like, well, last chapter, is a parabola. So we have a U-shaped line, a straight line, and a curved line. So if you were given a picture of different graphs, functions, you'd be able to decipher just by looking at what it looks like. Okay. U-tries you're going to be doing in class tomorrow, so skip those next two. Go on down to example 2. And what they're asking you to do in example 2 is we want you to graph the following exponential function and state if there's growth or decay. This is where those previous notes we just did will come in handy. Okay, for A, y equals 1/3 x. Well, what we want you to do to graph an exponential function, you can do this in your calculator, but we want you to practice doing it in the table first. So make 5 points, -2, -1, 0, 1, 2, just like we did in the other example. And what you're going to do is plug these x's in 5 times to find your y. So the first one, I'm going to do 1/3, and I'm going to plug in -2. Now this is a review. Remember, you need to distribute that -2 to the numerator and the denominator. So we have 1 to the -2 power and 3 to the -2 power. So we know we basically have to switch these. Get the markers. There you go. So we put 1 squared on bottom. Remember, when we move it, the negative goes away, and we put 3 squared on top. And when we simplify that, 9/1. So our first point is -2/9. We do the next one, 1/3 to the -1 power. Review, 1 to the -1, 3 to the -1. Switch those, so we have 1 to the 1 power, 3 to the 1 power, -1. 3 is our next point. 0, 1/3 to the 0 power. Anything to the 0 power is 1. And the bottom two are easier. So 1 to the 1 power, 3 to the 1 power, that's going to stay as our fraction, 1/3. And our last one, 1/3 squared. Remember, distribute that 2 to both numerator and denominator. We have 1/9. Okay, so let's graph those. So we have -2, 9. -2, 1, 2, 3, 5, 6, 7, 8, 9. Almost up there. So -2, 9. -1, 3. 0, 1. 1 and 1/3. And 2 and 1/9. It's so close. Connect that as best as you can. And try and do that. Okay, so we should be able to, just by looking at this, when it decreases from left to right, it tells us that it's a decay. Okay, so just by looking at this, we can see it's a decay. But also, as a reminder in our notes, when b is between 0 and 1, which remember, y equals ab to the x power, a is essentially 1 here, 1 times 1/3. So our b is between 0 and 1, so that again signifies a decay. So 2 ways you can tell this is decay. Alright, looking at the next example, y equals 5/2 to the x. Let me make my table. -2, -1, 0, 1, 2. Okay, I'm going to take my x's and plug them in to find my y's. So 5/2 squared, negative. So I know I have 5 to the -2 over 2 to the -2. I switch those to make them both positive. 2 squared over 5 squared is 4/25. We want this in as a fraction. Next one, 5/2 to the -1 power. 5 to the -1. 2 to the -1. Switch those. 2 to the 1 over 5 to the 1 is 2/5. If I put a 0 in here, anything to the 0 power is 1. 5/2, all of the first power, I know I'm going to end up with 5/2. And last one, 5/2, all squared. When I distribute 5 squared, 5 squared over 2 squared, I get 25/4. Alright, so we have fractions, which is what we want. When we graph, it might be a little tricky. So you want to convert these to decimals. In your calculator, you get 0.16, 0.4, 2.5, and 6.25. So let's graph those points. -2 and 0.6, so little. -1 and 0.4, almost midway. 0, 1, 1 and 2.5, and then 2 and 6. 1, 2, 3, 4, 5, 6. 6.25. Connect those. Okay, so we graphed it. Now we need to know growth or decay. Well, we know since it's growing from left to right, or increasing, I should say, not growing. Since it's increasing, it is a growth, exponential growth. Okay, and then just another reminder, when b is bigger than 1, which it is in this case, 5/2 is 2.5, we know it's a growth also. Alright, now switch over to that, these next two you're going to do in class. Switch over to the last example. Now take out your graphing calculator, you're going to need that for this one. Okay, so using your graphing calculator, we want to describe how each of the following functions differ from the parent graph of 2 to the x. Okay, so if I switch over here, let me see if I could. Position this over so we see both. Okay, so we need 2 to the x. So in your graphing calculator, get to the y equals, okay, and we're going to plug both equations in at the same time under separate y1, y2. So if we plug in this first equation, 2 to the x power, we have 2, and then hit the little rooftop button that's to the power of x. Okay, and then we're going to go down to y2 and type in our second one. We have 2 to the power of x, and make sure you arrow over, plus 5. Okay, so we're going to be comparing our parent graph with A. Okay, so this first one over here that we did, the bottom one, this is our parent graph. So our parent graph is going to always look something like this. So what is A? 2x to the x power plus 5. Well, it's going to be shifting up 5 units. Okay, so if we go back and we try the next one, just go up and actually clear that one out. So now we're going to compare B. What is 2 to the power of x plus 5? How does that compare to our parent graph of 2 to the x power? So we have 2 to the x power in there, so we need to see what happens when we do 2 to the power of x plus 5. So we plug in 2, that little rooftop button, x, and then, whoops, it didn't work. Try it again. 2 to the power of x. And don't use that arrow key. All you're going to do is go plus 5 right away. So everything's going to stay up in that exponent. Let's see what that graph looks like. So that graph shifts 5 units to the left. So when we did shifts before, remember what you would think positive, it's going to go to the positive number, it's going to go to the right, actually is the opposite. So it's going to be going 5 units to the left. So you can take a guess as to what's going to happen in C. If we have 2 to the power of x minus 5, take a guess as to what happens. Let's plug it in. 2 to the power x, I'm sorry, not plus 5, minus 5. What happens to that graph? It's going to shift 5 units to the right. Okay? Practice the last you try. Make sure you fill out the bottom when you are finished, and we'll see you tomorrow in class.